who will be talking about the preparation of data by NOAA staff for ROMEX.
Do I do this? This? Oh, great. So I think this is the third time I give the same talk, but because it's so important, so I want to say that clearly and slowly. And I think yesterday, probably like Bill mentioned that this is actually a group we should push the boundary using our data as much as we can. And then in the past 5 years, actually, we have learned a lot from Cosmo 2, also commercial satellite, right? So I think I actually have learned a lot about this practice of the processing and collecting so many data. So this is my experience to share with you. I think I published this paper in 2019 that some of you are co-author and Rick is also the author to summarize what we have learned from Cosmo 1. And then in that paper that I mentioned, well, Cosmo 2 is coming, and then we expect the higher signal-to-noise ratio can help us to deal with something we cannot do for Cosmo 1, which is penetrate much lower, higher observation, lower observation error, better quality, precision, and something. And then maybe this is the time we can think about that. Did we reach that? Second thing is actually this chart that we want to see if this data can reduce the observation uncertainty at the lower part, and also, of course, push as high as we can, as Bill mentioned, right? And then commercial satellite instrument come, and then they have a smaller signal-to-noise ratio. We will think about that. Maybe that's not a good idea. How much we have learned about that? So I think this is actually something that I want to present here. And the main question is, okay, how do we know about this high signal-to-noise ratio we have learned? And the different our receiver give us the same data quality, and can we using all our data just as we did before to generate this climate data record, and it's so great that IPCC access to write a specific section. Okay, so this is my question, and also I have learned that the antenna pattern actually do affect our retrieval result, and so I'm going to talk about our approach and some result and give my conclusion. I think Yang mentioned this, and in the comparison, we noticed this, that actually Cosmo 2 processed by UCA have relatively positive bias compared to ERI5, and others have a little bit negative bias. And then during this previous ROMEX meeting, that we find that different center using whatever data, and their control run is Cosmo 2 and our mission, and then they add more data from commercial, from whoever, and most of them then have a positive and negative impact, but they do all find the small geopotential, let's say, anomaly in their result. And then, although it's not big, but they're actually kind of strange. So I look into this small bias in much detail and see how much we can learn. And in order to do this, it's not very simple, because Christian mentioned that we process many RO data ourselves. And we have this 6 different functions, try to process the data so that we can understand it from very beginning to the end. We do the monitoring, we compare with others. So we do most of this in our product. So you can freely download it. And not only that, but we also go through many boxes to try to understand the data itself, because that's actually is how our data should do, our center should do, because other data differences maybe is 0.5K, but if we have a 0.1K uncertainty at a certain level, okay, we need to find out what's going on. Otherwise, AS team going to kill us. Okay, they already hate us. Okay, but and then MS the ATMS team, microwave team going to, hey, okay, like my colleague changes, so I say, okay, Ben, I need to talk to you. Okay, so this is how we do. And then I finish this processing, but not only that, but our mission, and then I put that in the website, freely download. And we have another poster, Dr. Yong Chen, going to tell us how we process those data by using 2 different independent processing methods. And then about the signal noise ratio, that I think we probably can learn, at least I've learned that high signal noise ratio, low signal noise ratio actually will make the penetration different. Okay. The high one, the penetration much lower. But because of different region, you have the dryness of the atmosphere. So it will not be penetrated the same way. Okay. But something struck me when the Cosmet 2 have a higher signal noise ratio, but their penetration height is a little bit higher in drier region, okay, compared with the Spire, compared with others. So this is one thing I noticed. And another thing I noticed is Cosmet 2 actually have an uneven distribution of the signal noise ratio. And the reason for that, compared with others, compared with Spire, compared with Plan IQ, and the reason for that is actually, Young actually mentioned, and I talked with Tom in the AMS, is why? And then I just realized that you have the antenna game, and then antenna, and then you move forward this way, and then in backward, you have another receiver. But if you see the sideway a little bit, then you actually see the side of that big that game pattern. So you have to see this way that you have a best game. Otherwise, you see this way a little bit that you have a lower game. Then your signal noise ratio will be probably smaller. And then this thing's actually bothered me for so long that I asked one of my staff actually do the simulation. He actually simulate everything, the pattern of the antenna, everything, and then he generated the distribution for the signal noise ratio distribution, which is exactly as I show you the real data, and then you can see the poster there. So this actually give me some confidence about the whole thing. Then we look at this so-called LSW. Then we find out, no matter how we plot the Cosmet 2 LSW and the Plan IQ 2 are a little bit larger at different latitude zone, okay? And then Spire and Maytop ABC are actually smaller. And no matter what, if this is actually tell you how the observation error for the different mission is, so this actually indicates something, okay? I'm not saying I understand all, okay, but this is may indicate something. And then we do so many different things. And then again, you can see the Vicky's poster to have more detail. And then we'll actually do this, try to see if we remove the model error, and then to calculate this so-called diagnostic observation error and how does the pattern look like over tropical region, actual tropical region, that you can see the Cosmet 2 is larger a little bit, and the Plan IQ is also larger, and the Spire is a little bit smaller, okay? So there's more things, and you can wait for Will's talk. Then these things happen that, okay, in the ROMEX period that we see the positive bias. How about we are using all the data I have, and then to repeat what we did before in the RO train things, which is collocate all the RO to RO data all together at the same height. And then I generate a time series, which is, I did that so many times. So this is what I do, and separate that with a different height from 20 to 30 kilometer and the different lat long region. And then I found out for Cosmet 2, this period of time, that they have a positive bias relative to Maytop data, okay, Maytop. And the reason I use Maytop, I didn't say that Maytop is absolutely correct. I just say that they have a longer time series, and then their high is stable, and their orbit is always the same. So I use that, okay? And that's actually what we used before in the IPCC, okay? Then I find that in different latitude region, that like a mid-latitude north, and we have this positive bias. If you see the south region, that the bias have this seasonal pattern, okay? I wonder why is that? And then in the 20 north to 20 south, that you see actually is like an increasing trend of bias itself. Then I asked my Dr. Jin Zhou actually going to present another poster to detail this, and then we wrote a JGR paper, and I think this is still under review. And then we plot this, a very famous plot, right? You have a reference, and then you have a sum of this bias with height, okay? And then the red one actually is for Cosmet 2. So others are kind of a relatively narrow, and the customer 2 seems from 45 nodes to 45 cells. And then I say, this actually is data is processed by us. So one of our processor result. Maybe we process differently. So I compare with UCA's result. Then I compare with my another result, which is RFSI. So this is how this different height. Let's look at the 200 millibar region. Upper panel is the mean time differences relative to ERI5. I'm sorry, the MATAP ABC, and the lower one is the standard deviation. So immediately I recognize in about 20 March that you have the standard deviation decrease, which is actually the time that ECNWF start to assimilate customer 2 data. Then I find that the uncertainty actually have this obviously pattern. And then the time series itself for UCA compared with other 2, which is processed by me but independently, they have a positive bias. And then if you look closer, that you can see it seems like I have a little bit positive, but the bias itself actually increases with time a little bit. And then you do that for different region too. Okay, then I separate that with a different latitude zone. Okay, the reflectivity 45 cells to 20 cells, and the upper is a 70 millibar, lower is a 200 millibar, and then I see the tropical region and everything. Then I realize over tropical region, the bias itself is relatively stable. And then over mid-latitude, south and north, that you can see there's a little more seasonal related variation relative, again, to MATAP ABC. Okay. Is this MATAP ABC? Yeah, I assume so. And the uncertainty actually have this variation. And I have so many different reasons, and then write that in my paper. Okay, you can go see that. But and then temperature have the similar things. Okay, then next step, as we do the IPCC, we do the inter comparison for this so many different data products, independent process by different centers. Okay, let's see how is the trend look like. Okay, so this is before we do the trend, we need to remove the sampling error. And then the way we trust our sampling error removing is we do that in 1 month. And then let's say we do this in using MATAP data. So we have a 1 month mean climatology, right? And then we do that for customer 1 in this case. And then we make a comparison. Then you can see they are very close. That's how that gives us the confidence about our sampling error removing, because these 2 samples are not the same. Then I do the same thing for MATAP ABC and MATAP and the customer 2. Then I find this bias too. This is very just as those bias as I find. So we are confident for our monthly sampling error removing method, and then we generate a trend, and then compare with one of this reference. In this case, is EI5. So okay, the trend have some bias, and if I remove the trend, that is very close to. So this one is no customer 2 data, so I use that. So I think we decided to using this to generate this monitoring climatology and put that in our website. That we think this is probably more consistent with the customer 1 period of time, because of this more consistent in terms of the mean and everything else. So I think this is my conclusion. I think I have learned a lot from ROMEX experiment, and also that I think my main things is if Dr. Vogt asks us to make a recommendation as the RO processing or data, let's say, group or center or whatever, now what will be the mission or instrument that you will recommend? I will say at least that should fulfill something, which is we should using as a backbone. That means as a reference that we can, let's say, compare with others and have a long-term stability and everything. Okay. And then this actually is, I found the way you make the antenna game and the pattern, the geometry actually, it's matter. So I'm very glad I learned something new that UCA confirmed with Tom, that, if you see the sideway, the game is lower, that this is the first time, beside my simulation, that I confirm. So again, there's a lot of publication and the presentation will follow, and let's try to make sure every step that we did is consistent. But you are very welcome to download our data to discuss this. But again, I think I'm just as I say that I'm very proud because we are talking about 0.1 mean bias, and then we try to find out is that the time series change, uncertainty, something. So I think we should be very proud. But we need to deal with this so-called mission differences even before the inter-center processing are not as consistent as before. So there's many things we can do, and I assume that we will discuss that in our discussion group. Okay, great. Thank you very much.
Thank you, Ben. I'm afraid we're very low on time, so no time for questions. I believe we have a short break coming up.